and I am presenting today with Mohammed and Mazen. In this presentation, we will discuss the differences between containers and virtual machines, focusing on how they compare in terms of performance, security, energy efficiency, and real-world deployment models. We will also look at the trade-offs involved and how modern systems combine both technologies to achieve the best balance. With that, let's move to the first slide. In this slide, I'll explain the main idea of our research. The study compares containers and virtual machines, focusing on how each performs and how secure they are. It looks, it looks at tests that measure CPU, memory, storage, network performance, and energy usage in both Docker and VM environments. The research also examines common security issues in containers and how extra security layers can change performance. Overall, containers give near native speed and use resource more efficiently, while VMs offer stronger isolation but with higher overhead. Virtualization allows multiple operating systems to run the same physical machine by using a hypervisor. This became the base for modern cloud platforms such as Amazon EC2, Microsoft Azure, and Google Cloud. Virtual machines provide strong separation and support many different environments. However, they have extra overhead because each VM needs a full operating system, hardware emulation, and more memory. This leads to higher latency and more energy usage. Rise of containerization. Containerization was created to solve performance issues found in VMs instead of copying hardware. Containers share the host operating system and kernel while still keeping application isolated. Technologies like Docker, Kubernetes, and LXC made application deployment much easier and faster. Containers offer near-native performance, very fast startup times, and simple scaling. This makes them more ideal. This make them ideal for microservices, DevOps, and edge computing. However, because containers share the host kernel, they face unique security risks such as privilege escalation and attacks between containers.
Hello, my name is Mohammed. I will explain the main differences between virtual machines and containers and give a deeper look on how visualization works. Virtual machines were the base early cloud systems. They run a full operating system and provide strong isolation and security boundaries. But the virtual machines also have trade-offs. They use more resources, they start slower, and they have a higher overhead because they most run in a full guest operating systems. Containerization is more lightweight. Containers give a near native performance, start very quickly, and use resources efficiently. Uh, let's go deeper. The virtual machines has a full guest operating system, virtual CPU, memory, storage, and input and output devices. All of these are controlled by the hypervisor, and we have two types of hypervisors. The first one, which run directly on the hardware, provides lower latency and better performance. The second one, which runs on top of the host operating system, make it easier to use but adding more overhead. Uh, In this slide, I'll explain how containers work, how they deploy, their security issues, and how they correct with the virtual machines and Kubernetes. Containers use operating system level virtualization. They share the host kernel and include only applications and its dependencies, which makes them lightweight. They start very quickly. They allow many instances to run on the same machine. Tools like Kubernetes, Docker, Swarm, and OpenShift manage scaling, scheduling, and container lifecycle. But containers also have security risks because they share the host kernel. Uh, one vulnerable container can affect the whole system. Common risks include namespace escapes, privilege escalation, and kernel attacks. Security tools like Linux and AppArmor help reduce these problems. Uh, okay, in this diagram, virtual machines offer strong isolation but use more resources. Containers are lightweight but face kernel shifting risks. Kubernetes orchestrates the containers by handling, scheduling, scaling, load balancing, and self-healing. Here in the next slide, uh, I'll explain performance differences between containers and virtual machines in terms of CPU, memory, input and output, network speed. Containers give near native CPU performance, usually only 2 to 3% percentage slower than running directly on the hardware. Virtual machines have a higher overhead of about 10 to 15 percentage because they rely on the hypervisor and visualized hardware. Containers also use from 25 to 30% less RAM since they don't run separate operating systems. Uh, they handle the software better, which means lower CPU usage and lower latency under the heavy workloads. For the input and output performance, virtual machines are around 20% slower because they use virtual desks controls. Containers access the host file system more directly, giving higher input and output speed. Uh, Network performance also favor containers in deep learning and data intensive workloads. Containers can be from 20 to 15 percentage faster than the virtual machines. But this speed comes with the trade-offs. Shared kernels, network namespaces can reduce the traffic isolation. Here in this slide, I'll explain how containers save energy and allow higher resource density compared to the virtual machines. Containers use about 8 to 10% less power than the virtual machines based than the virtual machine based systems during long running workloads, which makes them more energy efficient. When containers run inside the virtual machines, energy usage increases silently by around 5%, but this setup improves isolation and security. This hybrid approach is common uh, in enterprise environments. Containers also support higher instant distancing. This means more application can run on the same physical hardware compared to the virtual machines. Overall, this high distancing helps organizations scale and reduce costs, but relying on the host kernel weakness isolation, which can make containers more vulnerable to issues caused by the other workloads or shared resources.
My name is Mazen Al-Hajjaji. I'll explain how VMs and containers differ in security, the risks containers face, and the mechanism used to protect them. VMs give strong isolation because each VM runs its own kernel, and if one VM is compromised, it doesn't affect other VMs, which reduce the attack surface. Containers choose the host kernel, which creates several risks such as privilege escalation, namespace escape, kernel level attacks, and misconfigurations leading to breakouts. Many of these issues happen when containers' capabilities are set incorrectly or when insecure images are used. To improve security, modern containers system use tools like CA Linux, AppArmor, and SCOM to limit what a container can do. Technologies such as Kate containers and gvisor isolate containers inside lightweight VMs, giving stronger protection, but they add about a 5 to 10% performance cost. Here I'll explain why hybrid models are used and how they balance speed and security in cloud and edge environments. Running containers inside VMs creates a balance between performance and isolation. Containers provide a fast and efficient execution, while VMs add a strong security boundary around them. This gives agility without losing VM level protection. Hybrid setups are very common in cloud and edge platforms. Technologies such as Google Clouds, JVazor, and Amazon Free Cracker use micro VMs to isolate containers, combining container-like performance with VM class security. Hybrid models also solve the usual trade-off between speed and isolation. By stacking these layers together, organization get better control, monitoring, and security with almost no impact on performance or energy use. Here I'll explain the final compression between containers and VMs and how to choose the right approach. Containers usually outperform VMs in CPU efficiency, memory usage, I/O speed, and energy consumption because they are lightweight. But this efficiency comes with weaker isolation, which can increase security risks. VMs provide stronger isolation and better security, but they use more resources and start up slower. Hybrid models like running containers inside micro VMs offer a middle ground. They combine container agility with VM level security and control. Choosing the right approach, use containers when performance, capability, and fast deployments matter most. We use VMs when isolation, complaints, or multi-tenant security is required. New hyperversors, better container security tools, and advanced orchestration system are closing the gap between security and efficiency, shaping the future of cloud, edge, and I2 systems.